Hello, my name is Pedro Leta. I live in Brazil, Curitiba, and today I'd like to present to you MicrogradTS. Micrograd was developed by Andrei Karpavy in Python. It's an autograd engine made for educational purposes. MicrogradTS is an NPM package that provides the same functionality as Micrograd with the advantages of TypeScript, so static typing and performance. The way it works is it provides you with a data type called value, on top of which you can perform several operations. Sadly, TypeScript does not support operator overloading, so those operations are just functions that take values as arguments. But the importance of having those functions is they can track the local gradient of each of those values on a bigger equation. Why is that important? Because when you want to work with a neural network engine, for example, you can track down the impact of the weights on the neurons in the end. And then you can go back and you can edit those weights following the gradient. So you enhance the neural network. How does that work on a real application? So for example, let me show you. You can have any TypeScript or JavaScript application, and then you can add the package with your favorite node package manager, like yarn add MicrogradTS. In the interest of time, I'm just going to grab a ready example and walk you through it. Let's say we have some real-world data processing that we want to predict using machine learning. We could have a list of inputs X, and real-world data says X gives us Y. First of all, we make sure we're using the value data structure. We can do that by using the toValues helper function. Then we can create a multi-layer perceptron with, say, 3 inputs and 3 layers. We can then iteratively perform backpropagation and forward pass on our neural network. The way this works is we have a loss function which measures how far off our predictions are from the expected results. We use backpropagation to calculate the impact of the neural network weights on that loss. Then we change the weights by a small amount on the direction that will reduce the loss, making our predictions more accurate. If we do that enough times, we can get a very fit model with satisfying prediction results. We can then test this by running the file, for example. As you can see, the loss value gets lower in each loop, meaning our predictions are closer to the expected results. For the future, I intend on adding support for GraphVis visualization of the value data structure, because as of now, I feel like data visualization is still a big advantage of the Jupyter notebooks compared to MicrogradTS. But that's about it. Thank you so much for your time. Please feel free to reach out on the GitHub repo if you have any suggestions. Thank you.